Hello everybody and welcome back. In this video we will be taking a look at the longer Orange 10 3D SLA, or better SLA LCD 3D printer, which is another one of the new resin based printers. This one is really small, smaller than some of the others that I've already reviewed and taken a look at. And I like this one because although it's small, it comes with a pretty good manual. The software makes a pretty good impression. The resolution of this printer is really low, but it does have a very bright UV source, and it has a multi-point UV source, which has some advantages for curing resin really quickly. And I think it's a pretty neat package altogether. So let's have a look at it. Let's see what we have to do to set it up. Let's have a look at what's in the box, and then let's take it through a test print. So from the box we take some playing cards, some latex gloves, some rubber bands, and a bit of paper towel. Is this really going to be a 3D printer? There's also some tape, 3 hex wrenches, a USB key and an SD card, 2 filtering funnels, the build platform. Now it looks like a 3D printer. A power supply, a European power cord, 250 milliliters of resin. That's cool. 1 scraper, 1 release film, and acrylic plates to build the cover that forms the transparent top. And last but not least, the printer itself. There's also a manual in the box, which is surprisingly good. I went ahead and I removed the protective film from the sheets of acrylic, and it's actually really simple how these fit together. They're just one pattern. And this just follows on all around. And that is also what the rubber bands were there for, because once you have it all in one piece, you're supposed to put the rubber band over it, and that's going to hold it together. That is simple but pretty effective, and well, so far it's true that it comes with some assembly required, but this is extremely simple. Let's see if we can get the rubber bands to go on. So, here we go. Right, so this is not the way to do it. Let's try again. And maybe this time we'll just start from the other side. So maybe it's not as easy as I thought, but it's also not that bad. If you pull it over the edge of the table, it is actually pretty easy. here we go. One protective UV insulated cover for our 3D printer. The 3D printer itself came fully assembled. This is all of it. It's not really that big. Pretty simple. Power connector, power switch, SD card slot, and display with touch interface, and the reservoir for the epoxy or the resin. That is in here. The FEP film is also already in there. The only thing that I noticed is my printer was really dirty. Really, there was a lot of dust on it, like it's been where somebody cuts wood or something, and that stuff really sticks to the FEP film, and it's also on the inside here. So I don't know how I'm going to clean this up, but I will have to do it at some point. The next thing that I will probably have to do is we'll have to get the build platform mounted, which basically only mounts onto this screw, but the height needs to be adjusted so it sits down level on the LCD. When the LCD exposes a picture, it should be flush with the build platform. That's the only thing that you really need to look for when you set up your printer. Once that has been leveled, you're basically done setting it up. And that's one of the things that I like about these types of 3D printers. They're really easy to set up, and it is really, you can quickly start printing. Getting them cleaned up and finishing the print and getting it to cure, that's what takes the time. But just starting the thing up, pouring the resin, that is super quick, and it's a lot easier than threading filament, heating up the printer, making sure that your nozzle's not clogged. Compared to that, these printers do really have an advantage. Later on in the print, this kind of fades a bit, but for a start, this is really a nice thing because it's so easy to set up, and you're really printing really quickly. So just for a minute, let's have a look at the manual, because I quite like the manual. On the beginning, it just says longer Orange 10 3D SLA printer. Strictly speaking, it's not an SLA printer as such. It is more or less a photo curing printer because it doesn't have real stereo lithography, because it's not actually focusing on the plane. It's just basically curing one slice after the other. There's a small difference in there, but let's just leave that. So it is a really nicely made manual, and whoever made this went into detail so people understood what they're doing, and I really like that. There are the precautions, and they're spot on. The packing list is simple. Putting everything together is simple but concise. It's one picture, and these few points, it just tells the whole story, and I like that. Setting up the printer, what are the things? What is everything called? How do you do every step? It's kind of all in there. Then there's how to generate your job file from your model. And they go into detail. They tell you a lot. They tell you how support works, why you have to do it. It is pretty nicely done. And although there's not a lot in there, it's more than other printers have, so I'm pretty happy with this. I really, really like the way it was done. They even go through the steps of how you clean it, how you dry it, and how to cure it in the end. It's simple, but this is a good manual. It really is. Setting up the build platform is pretty straightforward. What you need to do is you need to remove the tank. Once you've removed that, you need a piece of ordinary paper, and you place that on top of the LCD to avoid scratching it and to have something between the LCD and the build platform that is roughly as thick as the FEP is, preferably a little bit thicker than that. After that, we can already mount the build platform, which is in its loose state. We tighten this with reasonable force. Make sure that this sits down well. The paper should be moving a little, but just really a little bit. Now we need to turn on the 3D printer. And it's quite noisy. And we've got the tool icon here. We can just press that. We can press the move button, and then we can go to the go to zero position or home position icon and just press that once. It's going to ask us make sure that there is no model below the build plate or in the resin tank, which is sensible, and we can say OK. What it just did its homing movement, and now the build platform is where it is supposed to be for its zero position. And what we can then do is really carefully tighten these screws one at a time. Making sure that the build platform remains on the paper and doesn't put too much pressure on it. So it should just be resting on there. And the paper should be relatively easy to move. This is not, because it is pressing down over here, so I'm just going to loosen this side up a bit and give this a chance to come back up. And once you've gone through that, yep, so we can move it up, remove the paper, put the paper back on, send it to the zero position again, and yeah, it's pretty good. So let's have a look at the specs of the printer for a second. The size of the print area is 98 by 55 by 140 millimeters. The resolution of the LCD below that is 854 by 480 pixels, which gives us a pixel width of 115 micrometers with almost square pixels. That is not as good as you can go, but it isn't so bad either at 0.1 millimeters. You can work with that. The power consumption of the 3D printer rated is 41 watts, which is, well, not so much. In fact, it's a lot less than most FDM printers, but I must actually say for 41 watts, I think the fan is pretty loud for that. But let's continue. So basically, there are a few differences between 3D printers that have LCDs and UV LEDs. You have two different models of doing it. Either you have one very large LED, which illuminates the LCD from the underside and shines through the FEP filter so it can build the object up to the top. Or you have the model where you have a lot of LEDs on the bottom, but the LEDs aren't as far away from the LCD as they would have to be with a single LED. The Orange 10 is this model. So it has a number of LEDs under the LCD, and basically each LED is supposed to illuminate a space under the LCD, but the one right or left of it can shine into that a bit, which causes ghosting. So although the pixel width is 115 micrometers, we can expect the pixels to be slightly larger than that. Just for reference, DLP or the standard SLA method is also there, but it works completely different. With these, you just have a laser and you have some mirrors that will move the laser beam along the FEP, and the object is basically traced. So every dot that is supposed to be solid in the resin needs to be exposed by the laser, and that can take a long time. Basically, it works a lot like standard FDM 3D printers work, and it takes a long time to illuminate or to go through all the layer before you can move the build platform. The LCD-based system is a lot faster than that because it can expose one layer at a time. So it exposes the layer and then the head moves. The standard SLA term is actually pretty old, and it stems from a setup where there was actually a laser and a lens above the resin that would hit the resin and focus the laser at the exact spot where it was supposed to cure the resin and form the object. But the build platform would be moving downwards into the resin, and it has the, well, disadvantage that you don't actually know how much resin you have cured, because when you cure the resin, basically the size of the molecules change. Also, it is really hard to keep the surface of the resin absolutely flat. So this is a very old concept, and it still works and it's still being used, especially for metal printers or powder plastic printers, but it is very much different from the implementation that we have over here, and that the longer Orange 10 has. So we have a printer that is built like that. Also, you will note that there is very little sensitive technology involved here. It doesn't need a motor, it doesn't need any mechanics that are, well, that have to be really complicated and big. It just has the LCD and the LEDs and a single stepper to pull up the build platform. So that's one of the reasons why these 3D printers are, well, so easy to use and why they're so easy to make. It's just a jump in technology from standard FDM printers. Now we can actually see the LEDs at work when I turn the printer on, and when I set it to the diagnostic mode and turn the LCD on at the bottom, we can then see the LCDs coming on, and this is the raster of LEDs that we have below the LCD screen. And yeah, that is very easy to see. Let's turn it back off and turn the printer back off. So let's have a look at the software. The software is wonderfully simple. It's called Longerware, and once you load an object, it just places it on the build platform, and if you select it, you get your 3 tool buttons for translate, which means move the object on the build platform, rotate, well, to rotate it on the build platform, and scale, which if you just select the object and pull your mouse up and down, it will scale the object. At the same time, once you select one of these tools, you can see what is going to change on the object itself, and you can really easily read the size in X, Y, and Z. This is probably as simple as you can make it, and it's just wonderful. I really like it. If you want something simple, then keep it super simple. You can also fix things in the object, so if it detects a hole or if it's non-manifold, it will attempt to fix it, which works reasonably good. You can then, once it's fixed, generate supports, which it will do for you, or you can manually add some. You can have the object lifted off the build platform, which is good if you have something that is round, for example. And all of this is super simple. Well, once you're done with that, you just click on slice, and it lets you select the thickness, and as I said, that is basically all you need. You can then go through the object and see what it looks like when it's being sliced, and after that you just click on export to save the job, which is down here. And once you've sliced it, you can even have your special recipe for the type of resin you're using and for the print speeds you want to run with it. Once you do that, it'll ask you for a file name. It'll save it with the LGS extension, and you can put that on your SD card and print it. This is so wonderfully simple. I don't know why other software can't be like that. It doesn't have special jobs, for example, for putting drain holes into the object or for generating special forms of infill, but that is the point when I want to have a special software. If I just want to have something that will slice it and print it, it can't be any simpler than this, and it's worked out fine for me. So the software definitely gets a thumbs up from me. It is simple, but it's really beautiful in being simple, and it just works out, which is, for this type of printer, probably what sells it the most. It just has to work. If you want something really specialized, then you want a software where you have all the bells and whistles, where you can tune every setting. But for a small and simple printer, this small and simple software package really sells it for me. Okay, now I prepared my print. I've got it in the SD card. I got the SD card in the printer. I've got the resin from Longer, and I'm going to pour this into the tank now, turn the printer on, and when I've got the printer turned on, I'm going to start the print. But I'm going to do this with the studio light turned off, because in my experience the studio light is a little bit too UV heavy, and it actually makes this stuff harden. So see you in a minute. So here we go. the resin is inside the printer. I did give it a good shake. Always shake this stuff before you put it inside, because the color will separate from the rest of the resin. And if you want it to look good and if you want it to cure good, always remember, shake before use. Now let's turn the printer on. And it's noisy. I'm going to select my file. There we go. And click on print. So the print process is running now, and it will run for about an hour and a half. I'm using one of the pre-supplied samples that are on the SD card, which is something that I always do because it makes you get kind of a feel for the timings that the manufacturer used to create a print that is supposed to come out right. And if nothing else helps, you can actually get a stopwatch and just time the times that they've used. And most of the time that will help you out to find out some good baseline settings for the printer software. So I'm going to let this run and come back every, I don't know, 20 minutes or so and have a look at it, how it progresses. But it looks quite nice. And it's still doing the bottom layers right now. You can see that because it's exposing longer than, I don't know, let's say 10 seconds. Usually the bottom layers are somewhere around 60 to 120 seconds, just to make sure that they stick to the build platform. So the printer's now finished doing the bottom layers, and it's progressing to the higher levels. And you can actually see the printer doing its gentle up-down movement every 10 seconds or so, and where it slowly moves up just a bit and then a bit further at a higher speed to separate the print output from the FEP and to make sure that it gets some fresh resin under the already printed piece, and that will form the next layer. You can actually see the stepper motor in the back going to work there, lifting the build platform up first slowly, then a bit faster, and then positioning it back down. And this is actually really simple, and it makes these printers relatively cheap to make because you don't need any expensive spindles, because it's all based on very simple movements. So it's about 2 hours later and the print is done. As you can see, it's still all drippy, and resin is coming off of it and out of it. And what I'm going to do now, and I need to turn the lights off for that again, I'm going to remove the build platform and let some of the resin drip off. And after that, I'm going to try and remove the print from the build platform. And I've got 2 glasses of isopropylene alcohol, number 1. And number 2 is right beside that. And I'm going to try to first clean the print roughly and then do a fine cleaning. And we're going to have a look at it then. And after that, I'm going to put it into my curing chamber for, I suppose, about 6 to 8 hours. Just to have it get all cured and hard. And then I can have a look at the part itself. So the print itself was completely uneventful. It just went through its printing procedure. Apart from being rather loud, there was nothing about it. It just did its job, which I expect. And when I'm done with this, I'll come back and show you the result. So I did get the part removed. It was a bit of a fight because I couldn't find the knife that I usually use for this stuff. And I'm just going to leave this in the alcohol for a couple of minutes. The alcohol is going to loosen but not dissolve the resin, and I can then just use gentle motion and kind of a brushing motion to get this off. It is quite important to get all of the resin out of here. And since people do ask a lot, once this resin is very much full, once the alcohol is full of resin, I actually put it in the curing chamber for about half a minute or so and turn it on, and all the resin in the alcohol solidifies, and I could just pour it through a filter and reuse the alcohol and get rid of the resin that was in there. I'll leave that filter in the curing chamber for another 2 to 3 hours, and you can pretty easily dispose of the hardened resin and keep reusing the alcohol until it's no longer usable. So we can already see that the print came out pretty good. There's a layer down here where I suppose there should be holes and drills and whatever. I don't know if this is sort of a raft this was printed on, but it appears to be there on purpose. So I suppose they wanted it to be that way. It's kind of funny. It looks really, really neat. So now that it is roughly cleaned, it gets another go in the other container of alcohol. Will stay in there for about 20 seconds, and I'm going to take it out. Let it dry, and then it's going to go into the UV chamber. we can turn this off, or we can leave it running. Nope. So there we go. So here we go. This here's the part that I printed, and it looks really nice. So bearing in mind that the resolution of the printer is only 0.1 millimeters, this still looks very nice. I can't actually make out any features from the edges of the pixels, even by looking really close, but that is to be expected because there are so many LEDs in there. We do get a little bit of washout on the resolution of the print that we're getting, but this is really nice. This is extremely nice. So let's get it into the UV chamber. So let's have a look at the sample prints and the prints that I sliced myself and how they came out. And in short, they came out absolutely perfect. There is nothing that I can expect more of this printer. So yes, I can see the resolution in the print, but it is so finely structured, it looks so clean, and all the surfaces are so great, and all the details are just the way you want them, that I, for one, am pretty much happy to live with 115 micrometers resolution. The speed was surprisingly good, which is due to the matrix LED under the LCD, which just makes it possible to go this little bit faster. And all the other details, the handling of the resin, everything that has to do with the print itself is just as good as on any other resin-based printer. I admit it might not be as pretty as some of the leaders in that field, but I can live with that. This is not a really expensive resin printer. It's not the cheapest either, but it is fairly reasonably priced. And I, for one, really like it. I was expecting some problems. I was expecting to see a lack of quality, but there's been none of that. So I really love the software. I love it for its simplicity, and I've been in contact with the guys from Longer, and it is possible to export prints using Chitubox software and to repackage it for use with the Longer printer. For whomever needs all the bells and whistles that Cheetobox has, that's a viable way to go. For somebody who just wants to get printing and wants to get printing fast, and who's happy to design his prints or to get his prints and not modify them, hey, you've got the perfect software there. The printer's also really small, and there's no quality problem with it. For me, it just worked. It worked really well. I had no problems. It was fast. It was a bit loud. It was louder than others, which isn't really a problem, but because you can't put this in your living room because it just smells so bad and because the fumes are potentially dangerous. So you will want to put this thing aside, and if it's been put aside, it can be loud. So I'm really happy with this thing. It was quite a surprise, and given the price, I would recommend it. I would really recommend it. It is a very small printer. It comes with a lot of stuff that the others don't come with. For example, Resin. The software supplied is great. The manual that you get is also pretty good. All the included stuff helps you get your first print out the door, but then you have to invest in time and material, and most of all you have to invest in isopropylene alcohol, because you need a lot of that. But this thing gets you going pretty quickly, and I suppose that's the best you can get. So that's it for this review. Thank you very much for watching, and bye-bye.